In the aftermath of James Webb's first revelations, the scientific world was stunned. What had been expected to be a slow unveiling of the universe's childhood instead turned into a jarring discovery of cosmic maturity far too early in time. The galaxies weren't just there, they were thriving. And their structures weren't chaotic as predicted. They were smooth, coherent, and expansive. This wasn't just about seeing ancient light. It was about seeing ancient complexity. And that complexity challenged our deepest-held beliefs. The early universe, as we understood it, should have been dark, scattered, and wild, a realm where matter was still coalescing, where gravity was only beginning its quiet work of pulling particles into stars. But now, thanks to Webb's ultra-sensitive infrared eyes, we were seeing mature galactic ecosystems with defined shapes and unimaginable mass. Some of these galaxies formed within the first few 100 million years after the Big Bang. At that time, space was still clearing its primordial fog, photons only recently freed from the dense plasma of the early universe. The very notion that such massive structures could exist in that environment sent shockwaves through every model and theory on the books. To put it in perspective, if you imagined the age of the universe as a 24-hour day, these galaxies appeared just minutes after midnight, and yet they already looked like the bustling metropolises of stars we see around us today. Their luminosity was off the charts, their rates of star formation blazingly high, some reaching 100 times that of the Milky Way. So how is this possible? One leading theory posits that star formation in the early universe was turbocharged. Maybe the first gas clouds collapsed faster than expected. Maybe the abundance of dark matter provided gravitational scaffolding that accelerated galactic assembly. Or perhaps black holes formed extraordinarily early and fed their surrounding environments with energy, encouraging rapid stellar birth. But even these explanations feel like band-aids. The growth was just too fast, too big. Theoretical astrophysicist Dr. Adam Riess, Nobel laureate for the discovery of dark energy, suggested that we may need to rethink the rules of cosmic evolution. And he's not alone. Some researchers propose that we may be underestimating the role of exotic physics. Perhaps gravity behaves differently in extreme conditions. Or maybe time itself is not as linear and uniform as we've assumed. Other fringe theories suggest interactions with alternate dimensions, or early universe anomalies that defy current models. And here's the real mind-bender. What if the universe is older than we think? The James Webb discoveries have reignited the debate around the age of the universe. While 13.8 billion years is widely accepted based on the cosmic microwave background and expansion rate, these massive early galaxies could suggest a longer timeline. If the redshift measurements we rely on are slightly off, due to phenomena we don't yet understand, then everything from the birth of the first stars to the timeline of galactic evolution may need revision. And that's not all. These findings have sparked an avalanche of new studies. Researchers are reanalyzing datasets, creating revised models, and launching simulations that factor in these impossible galaxies. Some simulations now suggest that intense bursts of star formation might have been triggered by large-scale cosmic web collisions, where filaments of matter intersected and collapsed into massive nodes far earlier than expected. Others are even looking back at Hubble data with new eyes, wondering if we may have missed similar galaxies hiding in plain sight. This is science in action, not retreating from contradictions, but running straight into them. Because every anomaly is an opportunity, and every shattered assumption opens the door to deeper truths. At Infinity Beyond, we believe these are the moments that define human curiosity, when the cosmos refuses to fit in our equations and invites us to expand our understanding. As the James Webb Space Telescope continues its mission, more mysteries will unfold. But for now, these ancient luminous giants stand as monuments to the unknown, galaxies that whisper a deeper story about the origins of everything. In the next segment, we'll dive into the tools and techniques astronomers are using to verify these early galaxy observations. How do they measure such incredible distances? What exactly is redshift, and why does it matter so much? And could there be hidden biases distorting what we think we're seeing? Buckle up! The universe is just getting started.